Sponsored by Panasonic. Smart factory solutions for any mix, any volume. Introducing the new NPM W2S, the ideal placement solution for manufacturers who value reduced setup and changeover time over volume.
Welcome to the Metcal booth here at SMTAi. I'm joined by Kit Westy, who is the Regional Sales Manager. Welcome, Kit.
Oh, good morning. Nice to meet you.
So, you've been doing a lot of things with connectivity of hand soldering systems into Industry 4.0 type applications. You've got in front of us here the CV5210, I believe. Tell us a little bit about this system and the features it has for data collection and for quality and monitoring.
Absolutely. So our new connection validation system is the first system in the industry that gives you closed loop feedback on whether or not you have a good or a bad solder joint. So it takes the same induction-based heating mechanism known as smart heat that Metcal has been famous for the last 35 years and adds power analytics to it, giving you the ability to see additional data about the quality of your solder joint. In addition, it has a live temperature display also through power analytics, allowing you to see a reference of your temperature and the part number on the screen. So we've added a chip to the cartridge, and in that chip we program the part number, the serial number, the lock code, and the temperature. And by doing power analytics, we can tell you whether or not that tip is going to work for any particular joint, give you a red light if it won't, a green light if you get a good solder joint. In addition, that data is logged to the microchip in the tip, giving you the ability to download that data as a comma-separated value file with all of the process data that your process engineer might want, such as the part number, the serial number, the dwell time, the temperature, as well as a graph of the power and temperature curves that can be played back at any time, giving you that validation of your connection and knowing that you have a good solder joint.
So let's break some of that down a bit. I mean, starting off with the temperature monitoring of the intermetallic. It literally senses just at the point where the intermetallic's about to wet and flow.
Exactly. So it's actually a four-step process how this does what it does. The first step is you put the tip down, the power goes up, and the system says, aha, I'm soldering. The second step is where it goes through what we call a preliminary validation. And that preliminary validation means that if you put a very, very small tip onto a large load, the power is going to go up and it's going to stay at some high level and never start to come back down. The system will recognize that and give you a red light telling you this tip is never going to melt that solder joint. If it then passes that step, it goes to liquidus detection. As the solder changes phase from solid to liquid, there's a brief blip in that power draw, and the system can measure it. So now it knows how much time and energy, how much heat has been put into the joint. It can calculate how much more time is necessary to grow the 1 to 4 microns of intermetallic that make sure that you don't have a cold solder joint and that you don't have an embrittled solder joint.
Great. So the next step is basically to take that data and take it offline, basically, and be able to feed it up to some sort of ERP system so that you can monitor what's happening and trace what's happening in real time, basically.
Absolutely, absolutely. So right now, the data is all stored on the chip, and you download it directly from the system to your laptop or your desktop computer. The next step in this product evolution, our vision for this is to have a dashboard where all of the deployed solder systems are visible in real time. What tips are being used, what power is being used, what the throughput rate is on the number of good and bad solder joints. So that's under development now, and that's the vision that we have for the future of this connection validation system, is to give that wireless data feedback as part of the Industry 4.0.
Any indication of when we can expect to see that?
I don't have a date right now. I would expect that we will likely begin alpha and beta testing next year in 2019.
Okay, great. Well, we'll certainly look out for that. Is there anything else that's new that's coming down the pipe from Metcal?
Absolutely. So what we've just launched for our connection validation system, when we launched it last year, it launched with just a soldering handpiece. We now have a high thermal demand soldering handpiece for your big applications and an ultrafine soldering handpiece for your micro applications. We also have two different tweezer handpieces, one for larger SOICs down to, say, 0402 components, and then another brand new microfine tweezer that's good down for 0201 and 01005 components as well for removal. And in addition, the same desolder gun that we've had for many, many years, we've now integrated into this system as well. So we now have a full complement of the hand pieces and tips available for the system.
Yes, you're going to have to be very careful when you're trying to work with 01005s because you could, damage them very easily.
It's extremely easy to damage them. For removal, you usually don't care about damage with the hot tweezers, so pulling them off. But for placement, what we found is that using a very low flow convection or hot air system is the best method. So we have a 200-watt hot air pencil called the HCT2-200 that gives you the ability to have 450 degrees Celsius airflow at only 2 liters per minute. So you can have the tip of the nozzle almost touching your board with almost no chance of blowing that component off, which is a challenge with any other hot air tool for 0105 or 201 placement.
Incredible, that's incredible. Well, a lot of innovative stuff there, Kit. I want to thank you for showing us it today, and we look forward to seeing the system when you've got it wireless and transferring offline.
Fantastic. Thank you so much for your time. Really appreciate it.